Hello, good morning, afternoon, evening, wherever you're joining us from. My name is Brian Benish with the Defense Systems Information Analysis Center, DSAIC. Welcome to the webinar presentation today. Pleased to have Justin Wolf with us. Before we begin the presentation, I just wanted to give a quick introduction to who we are, DSAIC, a little bit of why we exist, what we do, go through a quick bit of logistics for the webinar, and then hand the balance of the time over to Justin. So DSAIC, we are the Defense Systems Information Analysis Center. We are a DoD entity, organizationally under DTIC, and we support the DoD research and engineering community by ultimately conducting information research on a variety of technical topics that are chartered to our focus area. We have technical staff that are here to help you find the information you need on any defense systems related technical topic of interest. We host these webinars as a way to kind of push out an awareness of information on work that's being done throughout the DoD research and engineering community, ultimately to help mitigate, reduce some of the inevitable redundancy that occurs just from a lack of awareness. So pleased to have Justin with us to present on MBPS. So then I would encourage just to kind of close out that if you want some more information about us as an organization, the website is the best place to consume information, find information on us, and then you can always reach out to myself, Brian Benish, the contact alias for DSAIC, or any other folks on staff. Be happy to talk to you about what we do. In terms of logistics for the webinar, for those who are dialed in exclusively and are not in the web platform of it, you will be able to download the slides from our webinar webpage on dsaic.org. So you can navigate there, dsaic.org, under resources, webinars, and then you can find this webinar presentation where there should be a link to download the PDF. For those who are joined in the web platform, you are going to be able to submit questions. I encourage you to submit some questions for us to address at the Q&A portion after the presentation. To do that, there's a little dialogue chat icon up the top middle of your screen. If you hovered over it, it should say View Audience Questions. What that'll allow you to do is, once you click on that, to add a new question, and that'll put it in queue for us to address at the end. So at any time during the presentation, if you have a question, you can submit it there, and we will address it then. I just want to briefly distinguish that from the attendee chat or the presenter chat that's on the left-hand side. You can certainly chat to us with some questions that you might have, but if you have any questions that are more technical nature for the Q&A, I really encourage you to submit it through the audience questions form at the top middle of your screen. And then final note, we will be recording this, so if you have any technical difficulties throughout, just rest assured there'll be a presentation of this or a link to it sent out later on. And I think that is pretty much all I wanted to say. So without further ado, Justin, I will hand the balance over the time to you, and I'll jump back in the Q&A portion. Go ahead, Justin.
Great, thank you, sir. So good afternoon, everybody on the East Coast. Good morning to those of you that don't find yourself on the East Coast today. Thanks for that introduction and a little background on kind of what brings us here. Again, my name's Justin Wolf, the Chief Technology Officer at Systicon, and what we're going to talk about is this concept of optimizing logistics outcomes and what the Navy's doing in this as part of their digital transformation efforts on a program called model-based product support. So model-based product support, consists, I guess, today. It was an OTA contract that was awarded 2 years ago now. And really there's kind of, I'll say, 5 major areas of focus when we think about this concept of model-based product support. Now, this might sound a lot like, some terms that might be familiar to some of you. Probably model-based product support isn't, unless you've heard of this particular program before. But the idea is that this capitalizes on the efforts that have been ongoing in things like model-based systems engineering. But the difference is that the Navy's looking to not only do model-based systems engineering, which is a key tenet of this effort, but understand the implication for mission outcomes and readiness outcomes and lifecycle cost outcomes, which maybe isn't traditionally part of the traditional MBSE scope, right? And so this is kind of this expansive effort to really think about how do we enable ourselves to even do analytics, perhaps like in use case number 1 here, by procuring the right data. I mean, that's always a key thing that we at Systicon hear about as we help customers do predictive analytics and do mission and readiness simulations and optimize spares and manpower levels. Is it's really hard to do on a program that's in service because, you know, a decade ago when we bought this system, we didn't think about getting the right technical data, having our FMICAs and FMIAs and fracas information and detailed cost data, et cetera, that we need to be able to optimize outcomes, right? So use case number 1 for MBPS is just simply transforming the way the Navy tracks for data for decisions, right? Model-based data. Use case 2 is, of course, managing your system configurations. If I bring the best spares optimization tool and best performance simulation tool available today to bear on a system configuration that's not accurate, right? That means that we're provisioning parts, maybe doing a level or location of repair analysis or predicting a level of performance in a GAO report to Congress. That's not really reflective of what's being fielded, right? So use case number 2 that's really enabling analytics is thinking about how we better manage our fielded system configurations, right? And so that's a key tenet of this as well. Use case number 3 is then, well, once we have that system configuration, well, how do we manage changes to it, right? A ship or an aircraft or a fleet of aircraft at various squadrons are going to transform over time into something completely different than they were at the beginning of their 30 or 50-year life cycle, right? No one probably could imagine the transformation that the C-130 will have undergone to get to where it is today. Even on the F-35 program, there's 47 different fielded configurations of that aircraft. So, you know, it's important to manage these changes and ensure that we're getting the right technical data package and maintaining that technical data package as the system evolves. And then number 4 is acquiring and integrating the sustainment data. So let's say early on in a system acquisition, we buy or pay for our OEM to perform a FMICA, right? So we understand all the failure modes, we understand all the failure mode frequencies, the criticality of those failure modes and things on the mission sets, and we've done a lot of analytics. But as we field that system, perhaps the OEM's shake and bake on a component that generated a failure mode frequency doesn't really align with the environmental conditions that we're seeing in the fleet, right? So we want to always continuously update our failure mode frequencies and reliability data and maintainability data with real data from the sustainment phase of our program. Today, for the DoD, that's a lot trickier than it sounds, right? That it's not a straightforward process to take a system configuration, load new information into it, and see what the impact is. So that's a key piece of this as well. Finally, I'll say that the reason why we're really here today is that what we're really after when we think about our contribution, that is Systicon's contribution to model-based product support, is once we have this data, once we're able to manage this data, what we really want to do is effective analytics with it, right? What it's really about is understanding how the evolving system configuration results or doesn't result in an acceptable level of readiness, or perhaps new projections for life cycle cost, and really enable us to get through some really detailed understandings of what we need to do with the system and how we can effectively, you know, manage that system over the life cycle. So we're going to really focus today on use case number 5 as we go through kind of what MBPS is, kind of again assuming that we've bought the right data, we're effectively managing it and managing the changes of that over time, right? And what this is going to allow us to do with MBPS is this detailed readiness and predictive analytics that really allows us to understand how our weapon systems are going to perform. So the presentation, when you download it, is very large. And part of the reason why it's very large is there is a small video that provides a little bit more background, kind of summarizes what I've just talked about in this, you know, today we're talking about thing here. I'm not going to play that because, you know, the latency typically on the screen share programs wouldn't really support very good video. So just be aware that it is a large presentation, but primarily because it has this embedded video in it. But at a high level, what I just pretty much summarized, but I'll just summarize that again for everybody, is our goal with model-based product support is to field and sustain that digital twin, right? And that with that data, we're able to provide a whole host of predictive analytics with a suite of modeling tools in MBPS that's going to allow us to improve our material availability, understand how changes in reliability impact our mission effectiveness, and just in general, increase our ACE above. If you think about this, we make a system more reliable, we'll have fewer maintenance events. If we provision the right spares, hopefully that means fewer spares. And if we evolve over time and with our changing system configuration, perhaps we can reduce manpower levels or reduce costs through form fit function replacements and tech refresh. All of these things should enable us to better understand our ONS costs, but then also effectively manage those and keep those as low as possible. So that's a key outcome, right? Maximize readiness, minimize our ONS costs. So today, why is this so hard? Well, as you all probably know, if you're involved in the DoD, the current state of supportability analyses and weapon system configuration and contracts and financial business operations, they're all in these very distinct systems, very distinct stovepipes. The failure reporting and corrective action system probably for your system doesn't align at all with the fielded system configuration or what's in whatever PLM program your program is using. And that's a problem, right? Because then it takes days and weeks to crosswalk all of these independent things and understand what's in SAP and what's in your PLM tool and what's in your MRO system, right? And try to understand how part numbers and things are all, versus LCNs versus NINs. Everybody's got a different kind of view on the world, and making sense of all that is very, very challenging and makes modeling something like an aircraft carrier and the air wing on the aircraft carrier very difficult, because it's this constantly moving target. And by the time you kind of get to a point where you're in a pretty good place from a model building or predictive analytics perspective, you get a new data dump and everything's different again, and you have to start that crosswalk process all over. What the Navy's doing with MBPS and just digital transformation in general through efforts like Noble and things like that is really allowing us to integrate all of these traditionally disparate silos, right? And bring together all of this information in a common way that allows us to leverage all of that data. And in our case, what we're most concerned about on our side of MBPS is enable predictive analytics very quickly, right? It shouldn't take weeks and months to build a model. It should take a few hours, right? Excuse me. There we go. Okay, so as we think about this, we have this and I'll say the other thing is most of our program offices, and this has been the case in every system that we've kind of been brought in to look at, whether this is through the Navy's efforts or some of the other Department of Defense entities or some of the other 24 different countries' defense departments, they're all kind of the same, right? They spend their days in the program office putting out fires, right? They have a problem, they react to that problem, and they gather all the right subject matter experts, they gather all the right expertise, and they go attack today's problem. That's certainly, and those people are heroes in a lot of ways, right? They're working their tails off, but it's very, very reactive in nature. And what we really want to get programs to is not just putting out today's fires, but staying in front of potential situations that prevent a fire from ever happening in the first place, right? I mean, if we wouldn't need the kind of heroics that we see on programs where we're expediting parts or working through diminishing material sources because now we can't buy this component. Right? These should all be things that we can anticipate, that we can get in front of well before it's a major program issue, and respond in an appropriate way that enables us to just keep clicking along nicely, right? And that's really the goal in automating this data aggregation, in bringing together the right information at the right time, applying machine learning and AI when it's appropriate, and using predictive analytics to understand potential outcomes and risk associated with those potential outcomes as well. But I mean, this is the program office saying this, across, PEO, MLB, but this really is a seismic shift in the way that the maritime workforce and aviation workforce executes processes necessary to sustain ships and submarines. And as the aviation side, as NAVAIR comes into the model-based product support program as well, it's going to really, I think, transform the way that NAVAIR program offices do the same thing as well. All right, so how does this all work, right? We talked about model-based product support is this holistic effort. Well, those 5 tenets that I talked about at the beginning, in collecting the right data, managing the right data, sustaining that data, right, as it evolves over time with changes and things, consists of 3, I'll say, sub-elements of the model-based product support program. When we talk about, I'll say, a traditional PLM role, which is once we bought the data, putting it somewhere and managing that configuration over time, what the Navy is calling Navy Product Data Management, or NPDM. So this is the configuration of all of our weapon system data, our reliability, availability, maintainability, supportability, and cost information, our product structures, what is the fielded system configuration, how does that system configuration evolve at different locations with different environmental factors on reliability, et cetera, et cetera, et cetera. Right, that's NPDM. I'll skip NCRM for a second because that's my baby, right? That's where I'm focused. When we talk about procuring the right information from the beginning, we think about this as TurboTax for acquisitions. The Navy Data Acquisition Requirements Tool, or NDART, provides that common data standards and acquisition approach to procure tech data for analytics. You can think about this as, how many times have program contracting officers or COTARs or whomever involved in the procurement of information struggled to identify what CDRLs and DIDs do we need to put on contract? What data requirements and what data item descriptions do we need to go procure? Well, NDART provides really a one-stop shop to, I'll say, make this as simple as possible, put things in the right format, referencing the right FAR paragraphs and the right kinds of information to do analytics, and really just simplifies the acquisition of data across the Navy. That then feeds the analytics part of model-based product support, which is the Navy Common Readiness Model. And the Navy Common Readiness Model, this is the place where we're going to analyze that information, analyze changes to that data, and then report out readiness, predict outcomes, optimize our weapon system supportability parameters, things like spares and manpower and location of repair and things, and allow us to really understand how readiness and cost are going to evolve. Right? If we take a budget cut, well, there's going to be an impact. Well, how do we minimize that impact? If we get more money, how do we best spend that money to get the right outcomes? That's really where the Navy Common Readiness Model is squarely focused. These 3 things can't operate on their own. We can buy all the right technical data and we can have analytics, but if we don't have anywhere to store it, it still becomes this manual spreadsheet game, right? And same thing with, we can have good data, but if we don't have analytics tools, well, why did we bother buying this information? So each leg of this 3-legged stool of model-based product support really enables us to use data effectively, provide program offices with predictive analytics capabilities that, again, optimize our readiness, maximizing our ASABO, minimizing our lifecycle costs.
Hey, Justin, this is Brian. Do you mind, as you're moving on to the next slide, just making sure to announce the slide number you're on for those who are following along with by phone?
Yep. So I'm on slide, that was just slide 6. Slide 7 is just a placeholder. Slide 8 is going to start to show the information associated with how we do this in MBPS today, or how a NAVSEA program might do this in MBPS today. And again, it starts with NDART. We need to buy the right things, store and collect it, and then use it for analytics, right? And so there's a whole kind of host of traditionally disparate IPTs that are in place with this. But we're going to start going through this here in slide 9. And what I'll do is we've got some, high level kind of, again, this is a lot of words on a slide here, but I'll get through these slides and then I'll show you what the dashboard will actually look like, and how programs can access it. So this workbench overview, right? This is all software as a service with also thick client functionality for those programs that are operating in a disconnected environment, or on standalone machines, or required to work on a standalone machines for a variety of security reasons. But the MBPS workbench environment is hosted in the cloud and enables us to do all of these analytics, at the tip of our fingers. It's approved on NMCI, which, if you're from a different branch of the DoD, they're all fairly similar. We've been through the ATO process now for the Air Force and the Army, as well as the Navy. So, it runs today in a CUI, or, the old FOUO environment. And the thick client is also available on SIPR, but we don't have an IL6 environment stood up yet. But that's just to say that this workbench enables us to bring together all of the information. Traditionally, you would think about these as the various LRUs or parts and their structure, the parent-child relationship that enables us to, let's say, digitally represent DDG 1000. With that, there's going to be a whole host of other documents. The tech manuals and engineering drawings and things like that are also, obviously there, as well as our product structure. For the purposes of readiness analytics, the tech manuals and things aren't necessarily something I'm super concerned about, but certainly other areas are. So it's very important that we think about NDART and the data collection process as quite comprehensive, right? More data than just what's necessary for analytics. The MBPS functions, we'll see this, as far as how we leverage the tools. There's some online training and things like that as well. But this dashboard that we can see here allows us to pick and choose what we intend to do and how we intend to do analytics. So let's say we have a design solution, or a set of potential design solutions. We have an electronic warfare system that has a set of parameters associated with it. Let's talk about perhaps a radar system as an example. That radar system is made up of many, many different LRUs and SRUs, maybe 7 or 8 or more levels of indenture in your parts breakdown. Each one of those parts is going to have a set of reliability parameters, maybe some distinct failure modes and failure mode frequencies associated with those. Each one of those failure modes probably corresponds to one or more positions in a reliability block diagram. Through NDART, we would have procured the RBD information from our vendor and understand those failure modes and criticalities across various mission types, or a design reference mission perhaps. And with that information, we can understand how that system is likely to perform across a range of budget scenarios. So what we're seeing here in this chart is availability, system availability on the y-axis, and cost on the x-axis. So there's some inherent availability present inside of our system based on all of those reliability parameters that we talked about, right? If we just fielded the system, let it run for a while until it reached a critical failure, depending on the levels of redundancy, things like that in the systems, there would be some amount of availability, right? It would operate for several hundred hours. And if we didn't have spares and people and maintenance capability and the tech data to perform maintenance at sea, then, that system would fail and it would be unavailable for the rest of the deployment, right? But it's not zero. It's important, right? We don't get a 0% availability typically on any system, right? There's always some amount of uptime before it fails. But as we start to make investments in repair capability and repair capacity and spares and manpower and support and test equipment, we're able to slowly increase our A sub O. Well, actually, you tend to see rapid increases in A sub O for smaller investments in this nonlinear relationship that we can see here until we eventually kind of run out of places to spend money, right? And that's when cost is way out far to the right here, where you start to approach the system's inherent availability, right? So the other side of your design parameter is, even if you had a perfect logistic support solution based on the reliability, based on the redundancy, based on the criticality of components in those, excuse me, in those redundancies, there's some inherent availability you just can't get above. And that traditionally is something less than 100%, right? A perfect system, would have 100% A sub O. And perhaps with very, very low logistics delay times and a very, very redundant system, online maintenance and things like that, you get fairly close to 100%. So whatever that is, right? But of course, an aircraft system or a helicopter is going to be much, much less than 100% as an inherent availability. So somewhere along that is a sweet spot, right? And so if, let's say, we're observing an A sub O fielded of, let's say, 72% in this case, there are some actions that could be taken to get to a desired A sub O, right? And that's important. There could be just buy more spares as one example, right? So that you have the spares available to perform maintenance when the system has a maintenance event required, right? That makes sense. There could be a situation where you need to investigate an alternative component, right? Maybe, there are some critical components that are driving your downtime, right? That's all part of the analytics that we're exploring here. And maybe there's another source of supply that has a more reliable component. That could be one outcome. You could perhaps resolve some obsolescence issues, right? Maybe really the problem isn't repair capacity, but really that there's some SRU inside of that thing that's just hard to get or requires some special tooling, and manufacturers don't make it often, so it has very, very long procurement lead times. So that could have an impact as well. And then you might also just implement some kind of AI or machine learning or condition-based algorithm that allows you to do a better job of fault isolation, thus not changing your reliability, but perhaps lowering the amount of downtime associated with that component, right? And then, of course, you might want to have some not just increased onboard spares, but understanding, that there's a limit, right, from a size and weight perspective to the number of components you can have on board. If we know the mission that system is going to be performing and the locations in which it'll be transiting through, you could pre-position spares so that you have a low quantity of onboard spares, but at each port, right, there's more spares available to replenish that system. Because we're taking in all that detailed information about operations, we're able to do that as well. That's all to say that each one of these potential outcomes, right, or potential, I'll say, courses of action will result in an outcome that will allow us to increase our A sub O. Perhaps not all of these are cost effective, so that's why it's important to model both the readiness implications and the cost to do it, right, in order for us to maximize the capability at the lowest possible cost, right? And this requires both optimization and simulation. So, this is kind of one example of an infinite set of decision support analytics that could be performed. But this is going to enable the Navy this capability to answer a whole host of what-if questions related to what if a supplier goes out of business and we need to, change to a new component? Which system should I buy as part of our acquisition phase? How does the choice of system, impact mission effectiveness? What spares do I need to buy? How many people do we need to have? If we start fielding unmanned systems, what does that mean, for ships in particular? There's a lot of maintenance that happens at sea. If we field an unmanned surface combatant, now there's no maintenance because it's unmanned. So what does that mean from a required redundancy perspective, things like that, right? I mean, there's such a significant set of potential analytics that can be run now that we're buying the right data, putting it in a place that's accessible, and enabling programs to do analytics very rapidly, right? So I'll kind of pause there. I've been seeing a ton of questions come in. And before I continue, I think it's probably important to address a few of those. So let's, I think if I click attendee chat and kind of scroll up here.
Let me help moderate this a bit, making sure all the questions from the chat are submitted in the queue. So yes, let me just reiterate again, the top middle of the screen, little icon for submitting questions. I encourage everybody to submit their questions there, and we will run through them one at a time. In fact, let me just, where is it? A way to view the questions as well. Forgetting how to do that. Here we go. All right. So you should be able to, Justin, see the question on the screen. I'll just repeat it just for the sake of those on the phone, and then you can maybe address it, and we'll go through these, like I said, one at a time. So the first question was about case 5 that you mentioned in the beginning. So are there any briefings available that you know of, at least for download, that provide more insight into the cases 1 through 4?
Yeah, for sure. Again, I'm the predictive analytics guy, right? And our software is the one powering NCRM. But for the other components for NPDM and NDART functions of model-based product support, yes. And we can provide some contact information. If you shoot me a message, I can make the introduction to the MBPS program office, which is part of PEO MLB. No issues there. Just feel free to reach out to me. No problem.
Okay, great. I don't recall your contact information. Was that on the front cover, or how could folks get that?
That's a good question. If it wasn't, it should have been, but I can make sure we can put it here. I can. I think I can just type it in the chat.
Yeah, and if you're okay with it, we're going to send a follow-up email to all the attendees, just so they have, if they weren't able to, had some technical issues or something, they know where to find the presentation and all. We can include your email in that if you don't mind.
Yeah, not a problem at all. And I just posted it to the chat, so everybody can spam call me all day. That's fine.
There you go. All right. Next question then. Let's jump over. All right. So I'm going to read this, see if you can digest it and respond. So in terms of MBPS, modeling broken processes won't drive actual change or identity where the processes need to change. How are you integrating continuous process improvement into MBPS to facilitate organizational change management? By the way, I love MBSE applications to product support management.
Yeah, so great question, right? And I'll say broken processes is a broad statement that applies to many things in the DoD, as I'm sure you're aware, Kyle. So it kind of depends, I guess, is the answer. So ultimately, model-based product support can serve in a couple of different areas, right? First is as part of any sort of value stream mapping or continuous process improvement or Lean Six Sigma initiative, there's always an idea to change something, right? Maybe that's depot repair, to reduce some kind of admin delay time or, increase the velocity or whatever that is. And there should always be, I'd say, the engineers and logisticians and depot artisans and everybody else kind of part of that continuous process improvement set of initiatives. But you can use MBPS to evaluate the outcome associated with that. So if we're thinking about what's the bottleneck and weak link in our organization from a readiness and cost perspective, MBPS can identify that for you, and then your black belts and the different folks that are involved in improving operations can think about, well, what can be done about that, right? Is there a depot capacity issue? Is there just this huge admin delay time in releasing contracts that's resulting in a higher than desired procurement lead time for replenishment spares, right? A whole host of different things. But the key is that once you have that sort of holistic view of operations and maintenance and supportability in general, you can really understand the what if outcome associated with a CPI.
Mm-hmm. That's great. All right. So our next question here is regarding slide 6. So maybe if you wanted to jump back with that, you can, but let me just read it first. So regarding slide 6, do you not also need the product support system data management feed, providing data on unique and common support provider predicted and actual performance and config changes to the support enterprise for the product? How does this data feed into the model?
Yeah, so today, right, there are multiple systems for configuration of what we bought, configuration of what's fielded, what repairs are being done, how much do those repairs cost, right? I mean, there's in NAVSEA, I think there's like 8 different operational systems that we pull from, and I think on the NAVAIR side, it's like 13, right? And so, yes, there's a lot, right? And however, what NAVSEA is doing, and NAVAIR's closely following behind to some of their digital transformation efforts, is significantly consolidating all that. So as an example, NPDM consolidates MRDB, ICAP, CDM, DOA, and at least another system that's all of that configuration and maintenance information, so that we now have a common view of what an OEM told us the reliability of a part is, what the fracas data in the field is telling us our reliability is, how long it took to perform the maintenance on that component, both remove and replace on the ship, but then also get it back from the repair pipeline, the connection to Navy ERP, so we understand how much we contracted for that repair or replenishment, and provide that in a common sort of lake of information, let's say, to do analytics with it. That all is fed through a set of APIs that enable us to pull that data on demand and set flags so that when there are updates, an analyst knows that there's more or better data or more recent data available for analytics.
Okay, got it. All right, that's great. Let's see the next question here. Matt B says, if you were not able to get the data from the OEM, would this program allow internally generated data to run through the process? So reverse engineering specifically.
Yeah. So yes, right. I mean, if you have let's use like the Aegis combat system as an example, right? The program was originally, I think, in the 80s, right? There's like vacuum tubes and stuff, right, for good reason. But they didn't necessarily have digital transformation then, right? I mean, there's a lot of like paper, delivered by the OEM, and so. But what there is a lot of historical information, right? So we know whether the OEM delivered detailed reliability and maintainability data as part of that weapon system delivery. We now have years of fielded historical information, right? We know the maintenance that's being done on board the ship by the sailors. We know that we've contracted for repairs with various OEMs. We know that we bought spares. And so, if you have an in-service system where, using NDART wasn't possible at the time because it's been fielded for years, there is historical demand, historical reliability, probably at least historical demand, and in some cases, adjudicated fracas data that we can use to perform analytics. And those are in Navy or other service system of records for MRO and cost data that can be leveraged to do analytics as well. So all is not lost if we haven't procured everything from the beginning. There's just a different starting point perhaps than programs that had the full breadth and depth of this capability from the start.
Mm-hmm. All right, great. All right, the next question is kind of a long-ish one with a little add-on that came through chat, so I'll try to stitch it all together here. So it says, as somebody who's submitting this question, as somebody helping to lead digital transformation and work in the aerospace industry, as well as the director of technology of a nonprofit association with over 2,000 members, I found that technology changes are actually the easy part of digital transformation. The difficult part is the required change of mindset from a linear problem-solving mindset to a holistic systems thinking mindset. Without getting too much into specifics, how do you get buy-in from both management and the boots on the ground? And then the add-on from the chat was saying, just to be clear, I'm not saying digital transformation is easy, but the difficulty ratio in my experience has been 80% people issues, 20% technology issues.
Yeah, I mean, you're not wrong, right? So there's a few ways. First, there's there's like the carrot and the stick approach to just keep it at two high level approaches, right? First, the carrot is, we have a different workforce than we had when the idea of digital transformation was new, right? And there's a different, I think, perception of the importance of digital transformation than perhaps a decade ago, right? I mean, where if you had tried to implement digital transformation efforts and I'll go back even more than a decade, but let's go back to like 2004, 2005, when we're actively fighting two major campaigns on the other side of the world, and there's an unlimited OCO budget. There's not really a lot of appetite to do things differently. They're just going to put an iron mountain in the field. They're going to spend what it takes, and they're going to get the job done, right? Fast forward to like 2012, and the first go around with sequestration, and then again, fast forward even further to where we are today, and you now have a DoD workforce that's, I'll say, a bit more technologically savvy than it was 20 years ago, and a DoD workforce that's kind of come to expect the kinds of things that digital transformation brings to bear, right? I mean, the idea of not having a digital representation of your weapon system is, I think, now kind of weird, right? So I think the mindset shifted a little bit culturally. The dollars have shifted a lot, from a department perspective, where we now have to kind of think about cost effectiveness, whereas maybe 15 years ago it wasn't necessary. And I think that those two things kind of come together to make the carrot approach of here's a way to make your life easier a lot better, right? And perhaps the better, it's always better if people enjoy what they're doing as opposed to feeling pressured into doing something. The stick approach is just, Congress has mandated some of this, right? And so there are many efforts underway via OSD policy, like some of the new 5,000 guidance and 5,000 UQ and things that say that programs have to do this. There's some congressional, some HASC and SASC language that's mandating this happen as well. And I'll say that's kind of the stick approach, right? That says, well, whether you have the cultural or budgetary pressures to do things like this, you kind of have to now anyway, right? So between those two, I think we've seen the cultural piece of this kind of fall in the line one way or the other.
Okay, no, it's great. I appreciate that response there. It's good. All right, let's jump to the next one. All right, all this talk of predicting reliability and making decisions based upon that is all well and good. But has anybody proved this can be done in a real world life, kind of V&V perhaps?
Yeah, so I think we're even beyond like science projects to prove that this is possible, right? If you look at what was done with Constellation class frigate during its acquisition process to the Future Frigate Program, FFGX, and what the program's currently doing to integrate a digital representation of what the OEM is delivering from a ship perspective with the many GFE combat systems that are going to be integrated on board that platform, right? I mean, that's happening, right? I mean, it is pulling from legacy data sources, integrating it into a common viewpoint with input from the government, program offices, and the OEM to build a digital frigate, right? If you take that one step further back, and look at the SPY-6 radar, that program's a pretty big success using digital tools to understand reliability and predict failures and redesign certain system components before metal was ever bent. You know, it's more complicated than just bending metal, but and that work resulted in the program being awarded the NAVSEA Logistics Program of the Year, and now Admiral Akana being awarded the NAVSEA Program Manager of the Year when she was still a captain. So, you know, and hundreds of millions in savings, right? I mean, I think the program award for that referenced $1 billion LCC reduction. On F-35, we've seen 20% increases in readiness. You know, lower cost per tail per year, still above program targets for budget, but significant reductions as part of their digital transformation efforts and wrangling control of data from the OEM. So, you know, I mean, I think it's been proven, right? And there's still, you know, it's a big department, so there's still a lot of programs and a lot of things that can be done still. But yeah, I mean, I think there's a pedigree here that makes this a viable, real thing. This isn't vaporware for sure.
Got it. Perfect. All right. Well, still into the abstract here. How do you decide which of the infinite permutations to model?
Yeah, well, that's a good. So I mean, there's obviously, like, you know, if we could just have the perfect system, right? It met all of our mission requirements and never had a failure. You know, that it wouldn't cost a lot to operate, and we'd be able to do a lot with it. In the, you know, there are a set of I'll say strategic or tactical things that can be done, and more strategic sort of things to explore. Certainly, you know, there are. I'll use an example, right? We had on a tactical weapons platform program, we had an all-day meeting planned to talk about cost reduction, and one of the primary elements of discussion were TDY costs, which, when you look at the program lifecycle cost estimate, was like 0.5% of the total lifecycle cost of the program. So, you know, in some ways, it's like, well, let's just strike this one from the agenda, because it's not, even if we got it to zero, it's not moving the LCC very much, right? And so you can start to prioritize things pretty rapidly when you understand the rack and stack from this holistic systems level against one another. And same thing with like reliability and maintainability improvement. You know, on your system, it's kind of a trivial task now to take a few hundred different ideas for RMIP program funding, model them all, and see which ones have the most promise, right? Even with some risk modeling in there as well. So, you know, there are an infinite number of permutations. There's only a few, maybe a few hundred, right, that result in any kind of benefit. And then beyond those few hundred, there's only a few that have available tech data, or, you know, whatever the case may be there as well. So, you know, this is really where modeling is important, in understanding those infinite set of outcomes and how those might play into one another.
Mm-hmm. Yep. No, makes sense. All right. So next question, back to the case 1 of 5 there. If there's time, which I think there is, would you be able to briefly discuss use case 1?
Yeah, so this isn't my. So basically, again, this is like the NDART is the TurboTax for contracting, and the idea here is, if you think about what traditionally what a contractor does, you have a contract officer does when they let a contract, is they go try to maybe take from the last program that seemed to do pretty good and get procedurals and things like that that correlate to that program with some changes made for their unique instances. And what we've seen is program officers reach out to program managers, and PSMs reach out to other programs that seem to be doing pretty good and say, hey, what did you do last time? What data did you buy? What kind of analytics does the new 5000.UQ say I need to run? Well, what data do I need to do that? Well, NDART puts that all right at your fingertips, right? Based on the kind of program that it is, based on, you know, what ACAT level and things like that, right? There are a set of procedurals and bids that are basically considered best of breed, so to speak, that enable you to buy the right or make recommendations for your program to buy the right tech data with templates for the procedurals and DIDs as well, if that makes sense.
Good enough. All right. Next question is, so is the intent to have the Navy move their sustainment IT tools like Vector to the MBPS solution, or is the intent to connect to those tools? If so, what is the timeline?
So I know there's a lot of IT tools that are out there, and I can't speak to, and I don't want to speak to that as in case I put my foot in my mouth. But I know there is a, sunset horizon, as part of MBPS. The idea is to reduce the number of legacy IT systems and consolidate information into one place. That not only allows us to do analytics, but also probably has cost savings. Again, I can put you in touch with the program office, who can perhaps provide more insight into the specifics around. I'm only aware of a few that are directly related to my, analytics work. But I'm sure that there are others and lots of IT systems that I'm not even aware of, and whether those are sundowned or integrated or surpassed by other parts of the digital transformation efforts like Noble and NAMS and NAS and all that. I couldn't say, but I know the right people who could point you in the right direction. So feel free to reach out.
Mm-hmm. Okay. Good. All right, just a couple more questions left here. So the next one is, are you modeling sustainment solutions on development programs, then using MBPS to evaluate accuracy of design and/or providing sustainment options during sustainment?
Yeah, so good question, Thomas. So it's really, there's a place for MBPS regardless of where you are in your system lifecycle. Of course, if you start with analytics early on, you can be confident that the thing that you're buying is the right thing, right? Whether it's a widget or a system or a fleet of systems. But always, you'd never want to just buy something, run some reports with MBPS, put them on the shelf, and then forget about them. You always want to come back and reevaluate that proposed system design later, right? And with in-service data to be able to maximize system effectiveness throughout the system's lifecycle. Because even if the system itself doesn't change, your operational parameters certainly will, costs certainly will. Maybe there's a different field of operations or different location in the world of operations, new use case, right? There's all kinds of things. So you always want to revisit these things in the sustainment phase to continue to maximize decisions.
Yep. Okay, well, let's see. The last question here, unless anyone can quickly get another one in queue. But the question is, how is legacy data going to be integrated into MBPS?
It is, right? So, CDMDOA and ICAPS, all the systems that are fielded, their data is currently part of ongoing model building efforts. So in the dashboard, you can pull from those legacy systems. And then I believe that over time, those legacy systems are just going to be migrated into NPDM. Obviously there are many programs that are currently fielded that weren't part of MBPS when they were, obviously first fielded. So, and they will continue to be utilized and sustained for decades, right? So it's important that we capture legacy system data as well, right? And that's certainly a part of the program.
Yeah, absolutely. All right, well, that is the end of the Q&A. Somebody reminded us in the chat that your contact information is here on the last slide, so I'll just leave that up for the moment as we kind of close out here. So pending any other last minute questions that come in, Justin, thank you for your time. Thank you for the presentation. You know what? As I'm speaking here, question came in. So the question is MBPS driving changes to maintenance programs?
Oh yeah, right. I mean, when you think about maintenance concept optimization, whether that be a LoRa or increased need for capacitization or increased manpower, right? This is giving program offices the info they need, so when they walk into a program budget review, they can justify why they need to make investments, right? And that's really what this is all about.
No, perfect. Good. Hey, well, thank you so much for the presentation, for fielding all the questions. You did a great job. I really appreciate everyone else here who stuck it out the whole time.
Yeah.
So I appreciate it. Justin, thank you so much.
Yeah, thanks everybody for participating, and have a great rest of your day. And again, feel free to reach out with any follow-up questions. I know 45 minutes is hard to dive into the depths of this stuff, but I'll stand by and happy to talk to anybody that has more to discuss.
Very good. Thanks, Justin. Take care, everybody.